I see so many people just default to like an ESP32. They'll just go for a module
Right.
because the module is pre-certified. And so then they'll just say, oh, well, I'm using a module. I don't have to worry about anything else.
Well, yeah, no.
I mean, I agree that there was one design review video that I did where I'm just like, oh, look, it's another ESP32.
And still, there's like a lot of tests still you have to do, such as spurious emissions. For example, if you place this module with an antenna somewhere, that's actually another great point, but I'll get to it. And first of all, is like, does the enclosure, how is that going to affect the antenna? Because the radio signals can easily bounce off the enclosure and create like some spurious spikes that you didn't expect.
Hello, everyone, and welcome to the Altium OnTrack Podcast. Today, we are speaking with Anton Tishchenko, who is better known as Dr. EMC and the founder of PCB4EMC.com. I'm your host, Zach Peterson, and this is something I am very excited to talk about because it's one of the areas I have tried to make it my mission to learn much more about. So this is going to be an exciting conversation. Anton, thank you so much for joining us today.
Thank you for invitation, Zach. My pleasure to be here. Yes, like Zach mentioned, I'm the founder of Dr. EMC YouTube channel and also developer of a PCB4EMC website, which is aiming to kind of analyze PCBs for mistakes and do some AI algorithms.
Yeah, that's funny you bring up the AI aspect because, I feel like everything we talk about these days has had AI infused into it. It's
Yeah,
almost like
right.
we're in the
Such a
late
keyword.
90s and we're in the late 90s and everything has to talk about internet. And now we're doing it with
Yeah,
AI.
yeah. So yeah, well, it's been mentioned that there are also different definitions of AI, and what I'm kind of doing is not strictly the most intelligent, artificial intelligent way of doing things. It doesn't involve machine learning. It's more of algorithm for checks of basic design mistakes which you can make on the PCB, such as the ground planes. Like we talk a lot about this, usually when we do design reviews and PCB designs. And yeah, this is something you can just check by analyzing the design files from like Gerber Viewer or ODB++. This kind of analysis you can easily perform. So it doesn't really involve learning as such from like artificial intelligence point of view, but it still kind of is intelligent artificially because you're doing it automatically, and you're not there isn't a manual person who's doing this work.
Yeah, well, with AI, there has to be some sort of benchmark, I guess, to which the designs are being compared, right? And I think it's interesting because, in PCB design, we rely so much on rules. So it's always like a rules-based checking. So, it's one thing to like say we're going to compare, these Gerber photo plots to 10,000 other Gerber photo plots and then decide pass fail. But I think when you have, a rules based thing, to me, it's a little more abstract how you actually build that data set and then set up a system that can automatically compare your test PCB with these rules.
Yeah, precisely. And the issue is like the issue with design rules in PCB layouts is they're only as good as you set them, right? And if you didn't set your design rules,
Yeah, exactly. You could follow the rules and it's the wrong rules.
so yeah, this is what we keep in the background. So in our case, we kind of like this is under the hood of the tool is how exactly it determines what is acceptable, what is not acceptable. But the aim of this tool, which is still a bit under development, is to give you an indicator. So it's not going to say pass or fail. I mean, a lot of people would love that, but it can't really like substitute a real measurement and a real test. It's going to be more of like have you follow the best design practice for EMC.
And I think it's always nice for maybe people who aren't EMC experts who follow these kinds of tools to get like a recommendation for a fix.
Yeah,
Maybe
yeah.
it gives them a path forward. So I think the best feedback is not just this is wrong, but here's the potential fix for this.
Yeah, I think I also like I watched a few of your 1 minute design reviews, and I mean, correct me if I'm wrong, but design mistakes are always the same, aren't they?
um, I would say that there are some reasonably common mistakes.
Yeah.
Yeah.
So this is a sort of thing I'm thinking of developing is this sign. It will just tell you like, is this design look? Does this design look like it's a good design for EMC, or is it gonna fail in every possible imaginable way because you haven't got a ground plane or something? Like, yeah, it's to spot those big issues, and it's like, what is it? 20% of design is giving you 80% of results usually, so we're trying to hit that and make sure we capture all the big mistakes. But it's always like, whenever I've like worked with design like for client, when it's always something simple. It's annoyingly like when you have a piece like EMC failure, you'd like sometimes you'd like something complicated to analyze, to debug, to calculate. No, never. It's always someone connected a chassis to ground, or like forgot to add transient voltage suppressors, or uh, like no ground planes. And yeah, it's always this kind of stuff that trips people up somehow.
That's funny you bring that up with clients because I talked a little bit about this with Eric Bogatin on an episode I think a couple years ago, and one thing that I had mentioned was that usually when a company has failed EMC and they start looking for outside help, they've probably gone through at least one round of testing. They've probably gone through multiple rounds of pre-compliance, and they have no idea. So they're probably ready to try anything. And so they just throw everything they can think of at the design. They just, you know, stitching vias, more ground pour everywhere.
Yeah, shield
Um,
everything. Yeah,
yeah, exactly.
three
Yeah,
times.
they just want to try everything because I think it's a lot cheaper to try everything and take something off rather than go through another prototype spin with each solution iteratively. And it ends up being a pretty substantial change to the layout, but I think there's usually that one simple thing that's really the root cause.
Yeah,
And if they don't know, they're just going to end up doing a lot of work on the design in order to get all those solutions in there.
yeah. So if it's a radiated emissions failure, then that means there's a pretty good antenna somewhere on a PCB that they don't know of, and
Yeah,
basically, and it's either it's in a cable, or it's in like an inductor, and all it takes is just to find it. But yeah, because they don't want to find it, they just put a metal enclosure around it and try to like isolate it, Faraday cage it as much as possible. And yeah, just some of those AMC fixes are insane.
put common mode chokes on everything.
Yeah, and
Yeah.
because they don't know what they're putting it on, they put it everywhere. Like,
Right, right. So one thing I wanted to ask you is, how does someone who's younger like yourself get into EMC? And the reason I ask that is because a lot of the folks who I know who do EMC consulting and, EMC courses, that kind of thing, um, they all have gray hair, let's say.
yeah, I think I will do as well soon. But yeah, it's a good question. I think I've started because I had to, because we had a lot of products that I've designed for audio. So I started off as a kind of audio product designer, and we just needed to get them done, and there wasn't anyone else who knew or had interest of really working on this aspect of design. So, but then, like, I think at some point I attended EMC course taught by Lee Hill. He's one of the legends with Silent Solutions, and I really enjoyed that course, and I think it's inspired me to do more research in this area. And yeah, it's just came kind of naturally, and also like now I don't know if you're aware, I'm also doing a PhD. I'm in the final stages of my third year, and basically it comes hand in hand with all the research I'm doing with electromagnetics, and I'm designing antennas for 6G. So kind of interesting concept, right? So yeah, it kind of helps to understand what electromagnetic propagation is like of real devices, and I see a lot of researchers actually lack that knowledge.
Interesting. One thing I point out to the EMI folks is the correspondence between SIPI and EMI, because they all kind of wrap together, and sometimes your SI problem is really the root of your EMI problem.
Oh yeah.
And
One could
I'm
argue that the tool that I described is really a SI tool, and it's a valid argument.
yeah, I'm surprised how many of those guys, as experienced and knowledgeable in EMC as they are, the SI correspondence is maybe they're not so well practiced in it, because I think they spend so much time on testing.
Yeah, well, SI, depends on what we mean about SI. A lot of it goes into the simulation tools for SI, and I think it's quite like typically when it's simulated well, it's not going to have a lot of EMC issues either. But the issues normally come from products that haven't been simulated for SI at all, and yeah, and the company obviously doesn't have a budget to do it, so you kind of can't sell them a 30 grand subscription to ANSYS or something, and they just laugh at you if you try. And so what do they do? And yeah, this is then they usually just go to a test house, fail it once, and then learn from it and try better next time. That's what normally happens. This is why we kind of there's like I stole this line from somewhere, but is pretty much a 50% failure rate on the EMC testing for the first time. That's I think is accurate. Like 50% of products that go into EMC test houses fail, and they, obviously that seems like a loss, but is a gain to EMC test houses. It's good for
Yeah,
them.
this is a good justification for maybe for young people to pursue EMC as a career, because as I mentioned, the current group of EMC experts, obviously being grayer than us, are going to retire
Yeah.
at some point. But 50% failure rate, I mean, that's a crazy failure rate.
You say it in any other industry, and yeah, it will have different effects. But somehow it came to like I don't know, at least in the UK, it's to the point of almost acceptance. It's like this. Some companies they would just plan for an EMC failure in their schedule, like they don't even assume that you're gonna pass. They assume you're gonna fail, and then it's just it's a bit demotivating, like because well, why you don't trust me or something?
It's funny because I'm sure they probably don't even call it an EMC failure in their budget. They just call it a round of
Yeah,
testing, and they
second round of
yeah,
testing. Well, why do you need second round of testing if you didn't fail?
exactly. Yeah, that's a good point.
So yeah, and it's very often is in the budget on a very high level. And
Yeah,
yeah, why
I
can't we do something about it?
and you brought up simulation tools, and I think it's easy for those of us who have experience with simulation tools to just say, "Oh, just get a simulation tool." But
Oh
I
yeah,
think it's
I
easy.
sit in a university. I get all the subscriptions for free, like ANSYS, CST, and they call us all the time, and they offer, would you like this? Would you like that? Please.
Yeah.
But yeah, if you go to the industry and it's like you discover the prices, you just go like, oh my god, really?
Well, not only that, but like the knowledge needed
And you need
to
to know how to run them.
effectively,
Yeah, yeah.
yeah, you need somebody who is a simulation expert,
Yeah,
has
it's a
that
full-time job, effectively.
exactly. Yeah, has that master's or PhD level, background knowledge about all the math that's going on to even get accurate results.
Yeah, it's quite challenging and yeah, very unattractive for like startups. Startups wouldn't even think or dream of doing something like that.
Yeah, that's true. Yeah, so I'm eager to see what some of those, AI based simulation tools can uncover because, like you said, I think if it can pick out the, one or two things that are simple, right? They're simple design changes, but they can lead to that EMC failure.
Mm.
That's a huge savings in the budget. Yeah, it's a good insurance policy if you ask me.
Yeah, I think that's definitely the plan, and one of the issues is that IP rights. A lot of companies don't feel comfortable about sharing their design. It's it's a very simple idea. You just get someone who's experienced to look at your design, and they pretty much tell you straight away if there's something wrong. You only need 1 minute for yours. So
Well, I spend more than a minute preparing that.
it takes
It's hard to
longer to
condense.
make, yeah.
Yeah, it's hard to condense stuff down to 1 minute sometimes.
Well, but still, like, it's possible to do that, and but many companies, like defense companies, they wouldn't want to do that. They would like, and this is a challenge. Obviously, they are very strict with even sharing their fabrication files to fabricators. They always sign NDAs with every fabrication house. So yeah, this is I don't really have a solution for it as much, but I highlight it as a potential problem that people should be aware of, I guess. And one of the reasons why it is how it is, because traditionally companies don't like other people looking at their things, and for good reasons. So yeah, that's why we can't just send a design to someone to have a look at. And but
Yeah,
yeah,
yeah.
yeah, I'm hoping that if it's just a neutral tool, like artificial tool, and it doesn't store any data, then maybe I can convince people to use it, but we'll see how it goes.
Yeah, and you brought up, aerospace and defense. I mean, I think if there was a desktop version of it, because
Yeah, like a
all those
desktop,
services,
yeah.
yeah,
Mm,
all those services, people try to make them cloud based, and that really crowds out the highest value corners of the
mm,
market and your potential user base. And it's funny because I talk to I talk to VCs and stuff who they want investment advice and opinion on companies and stuff like that. And they're looking to invest, and a lot of them queue into hardware companies, and they just don't seem to get why people don't want to use a cloud service a lot of the time. And it's for the
mm.
exact reason you brought up.
Yeah, it's not as secure, is it?
Yeah,
Yes,
exactly.
definitely like desk tool, or even like because you have plugins as well in your PCB design tools, such as KiCad or Altium Designer. You can install a plugin, and it could be that.
Yeah, the plugin idea is great. I mean, for the non Altium users out there who might be listening, if you look in Altium in the extension section, there's this big list of additional extensions and integrations, and it's actually really cool that you can do
Mm,
that in
mm.
the design tool.
By the way,
Yeah.
I saw you used on your recent video this S11 analysis. How did you make that happen? Was that part of Altium, or it was done completely externally?
So that was done with Symbior.
Ah, okay.
Yeah, but that's another it's not a direct integration, but what's nice is that you can do an export, like for example, from a stack up into Symbior format, and
Yeah.
then just really quickly import it, or you can just output the ODB files
How long
and then
did
put
that
those into
take
the simulator.
to output and set up the simulator? How long did it take?
For the fast SI simulator, just a matter of minutes. It
Really?
doesn't take very long. Yeah,
Okay.
yeah. It's not the full 3D simulation. Once you do the full 3D
Yeah, you
simulation takes
don't need
a
to,
little bit longer, but just to do the outputs and then import, it's pretty quick. So
because it was
I think
quite
there are
impressive.
some.
Yeah, because highlighted immediately all that you have a lot of issues on that trace, right? And it's a lot of reflections and things.
So they already do the signal integrity simulator in Altium Designer, they already do the calculation of each section of the trace. So it's a pretty
Hmm.
simple matter to just display the impedance values somewhere as like a heat map, you know.
Yeah.
And you could do it with the Symbior SDK. So it would be really interesting to see that as a feature add, and then do a direct export over to Symbior for any further analysis or something like that. I think that would be really cool.
So the reason they didn't do it is because they don't have resources, or why?
No, I think fairly they've been focusing a lot on the cloud deployments and things like that because it is pretty useful as far as data management, and then I'm sure there are enterprise customers that want that. So you could say it's
Hmm.
limited resources. I mean, I say it's attention placed elsewhere, and I think it's fair.
Right.
I think also, if people knew that this was a thing that you can do, but they don't
Right.
see it, they would demand it more. But I think because people don't demand it more, it
Hmm.
doesn't end up in the new version, which is
Yeah.
also fair, right? I mean, you try and be responsive to users.
Yeah. That's actually a good point. Is you raised is awareness to EMC. In it tends to be quite low in general among PCB designers, isn't it? It's, just happens
Yeah,
at the
I
end of
think
the project, and then they kind of almost caught up by surprise that suddenly there's like all those requirements apparently apply.
well, I think that's where the rules of thumb come in, and people try to rely on some really basic stuff with rules of thumb to
Mm.
then get around a consideration of some common stuff with
Yeah,
EMC.
but they don't work like because if you have so many industries like aerospace, defense, railway, commercial, and residential, all that stuff, you can't apply one rule to everything. So this is a very common thing to experience is that you start with something and then as you apply those environmental things you can't even like selecting COTS parts like if you're just selecting something like a power supply and if this decision is made early on in a project it becomes really difficult to change it later in a project when you suddenly discover that you need to apply some standard that this COTS power supply just simply doesn't comply with and what do you do then? So, yeah, that's what I mean by this awareness to EMC is, yeah, it needs to be really, it does need to be designed into from the first meeting or from the first project requirements specification iteration. And yeah, it doesn't seem to happen. So maybe that's why you don't get asked as much about it as you should be, perhaps, in terms of Altium designer as well.
Yeah, I think that's fair. I think another aspect to that is that even if somebody does know it's important, sometimes the requirement as far as the standard that they need to operate under, they probably don't know which standard it is, or if they do, they don't know what the requirements are in the standard. And there are some component manufacturers who are really good at stating specifically, if you do this, you will be compliant with this standard, which is helpful. But I mean, what percentage of components is that? Like, for example, with brick
Yeah.
power supplies, is it 20% maybe?
Mm,
It's kind of a shot in the dark as to whether or not the one that you pick that's actually going to give you the performance is also going to give you the EMC compliance.
yeah. Yeah. And for what industry? Yeah. So that's the
Yeah.
other thing I started doing is I started kind of compiling different industry specific knowledge into video courses and so I've the first video course I made is about radio so when you have intentional transmitters in your product and so in US you need to apply the FCC or regulations obviously but in Europe we have a thing called ETSI European Telecommunications Institute and they publish a lot of standards so even though the standards are mostly different they mostly the same at the same time because they all kind of pursuing the same goal. So and yeah, if we start looking at things like automotive, electronic equipment, it will be a completely different group of standards and completely different group of tests, like uh, which often trips people up as well.
Yeah, I think that's a great point. Now, one thing that you just brought up was radio.
Mm,
And in order to, I think, get around having to even deal with radio standards, I see so many people just default to like an ESP32. They'll just go for a module
right.
because the module is pre-certified. And so then they'll just say, oh, well, I'm using a module. I don't have to worry about anything else.
Well, yeah, no.
I mean, I agree that there was one design review video that I did where I'm just like, oh, look, it's another ESP32. And it's like, I think they're great learning tools, but like, you can't rely on ESP32 for everything.
And there's like a lot of tests still you have to do, such as spurious emissions. For example, if you place this module with an antenna somewhere, that's actually another great point, but I'll get to it. And first of all, is like, does the enclosure, how is that going to affect the antenna? Because the radio signals can easily bounce off the enclosure and create like some spurious spikes that you didn't expect. So it's still like lots of testing you still have to do, even if you select a module based approach. And yeah, so the other point is the antenna itself, like, because if you didn't go with antenna, so what I like about FCC is that you can access every certification report online uh, quite easily for like CE compliance testing. A lot of folks never publish anything because it's, well, very often they don't do any testing, and they would just sign off the DOC and keep it to themselves. But the point is that you don't have to publish it. There's no law that requires you to publish it. Whereas with FCC, it's really good because it requires you to have this publication uploaded into the FCC. So all the FCC reports are available online, and you can see what antenna has been used, what configuration's been used, what the test setup was, everything. And typically the recommendation is that when you buy a module, you need to use the same antenna that has been used during the testing, and then you can kind of mostly assume compatibility. But what if you don't? So like, if you if you specify a different antenna, which, like, instead of 2 dBi gain, it has 6 dBi gain, where does that put you with the regulations in terms of EMF assessment, with the spurious emissions assessment, with the TRP, TIS assessments? So basically, you have to do everything again, isn't it? Because you can't just assume that is going to comply now, because you have a completely different antenna. The radiation pattern is completely different. The gain is different, and you need to repeat all the measurements. So it doesn't always simplify things, actually.
Yeah, module certification only gets you so far.
It only gets you so far, exactly.
I think the other aspect of it that is attractive is that you at least know the module antenna works if you just follow like a couple of rules.
Yeah, functionally it's easier to design. What
Sure.
I've what I've been recent now, that might be interesting for readers to learn as well, is was that there's a new thing in town called antenna on chip, and that becoming increasingly popular. And what I recently discovered is that you can't rely on antenna and chip in the same way as on a module, because once you put your antenna on chip on a PCB, it changes completely. Once again, you have to follow exactly the same PCB as been used during the assessment. So you need to kind of match the stack up, match the distance to the ground plane, match the size of the ground plane. And if you don't, you get a completely different performance.
Yeah, that's a good point, especially with antenna on chip. Because going back to the module, you'll just see somebody, overhang the antenna, off the edge of the PCB, or they'll do a cutout. And for the most part, at least functionally, it works. But then
Yeah.
once you throw it onto a chip, that chip is then overground, there's a whole stack up that goes along with it. I think it totally changes everything.
Yeah, yeah, and it does, yeah. And it comes as a shock to a lot of people.
Yeah.
If,
Yeah, I haven't used any antenna on chip yet, but I'd be interested to see how that
yeah,
works.
don't.
Yeah, I'm sorry.
Don't.
Don't. That's fair. That's fair. Yeah, the closest I've gotten was antenna on module, but not like the meandering F antenna that you
Hmm,
have, or the meandering microstrip antenna. They basically just have like a small, ceramic that they put
right,
on there, and then that's your emitter. So you never see the antenna, but it's broadcasting and it's connecting to your Wi-Fi.
right. Hmm.
Yeah, those modules are always fun to play with. So switching gears here to the EMC courses that you mentioned. You mentioned radio. Um, what are some of the other industry specific courses that you're focusing on?
Yeah, well, I'm working out this automotive now next. So the next one is going to be about automotive electronic equipment, and yeah, then on I will also do railway, I think, for sure. Um, it would be interesting to do medical because it's become really strict recently.
Yeah, medical would be interesting, and that's actually one of the. I think that's one of the areas that is very high value,
Hmm.
but very esoteric
Yeah, yeah,
compared to something like radio.
yeah.
And then what about like mil spec?
Mill, yeah,
Yeah.
that's also a very interesting one, but I don't have quite as much experience with it though. So that's
Okay.
yeah, it would be good to gain that experience first.
Yeah. Yeah. Of course. So one thing you also mentioned earlier was you're working on a PhD.
Hmm.
If you could tell us a little bit about the research you're doing for your
Oh
PhD.
yeah, yeah, absolutely. So it's not very related to EMC, but I think maybe we should write a paper together about EMC. That would be cool. Haven't I've never done any EMC papers, but yeah. On my current research basically is about what we call intelligent mirrors. So for 6G, we are proposing that we gonna instead of antennas, well, not instead completely, but to supplement the antenna layout, we're also gonna have intelligent mirrors on surfaces implemented at various positions on a street or in a building or inside a building, and those will help to steer the radio signals from the base station to the user. And basically, these can be either passive surfaces, so completely metallic and without any circuitry, or they can be also active surfaces, which is all based on the theory of metamaterials. So we call them meta surfaces, and so those passive and active meta surfaces is effectively what my research group is focusing on.
So just for myself and maybe for some other folks, when you say metasurface, I think this is a little abstract. I'm a little more familiar with the idea of metamaterials, but not metasurfaces. My understanding is that it's precisely engineered geometry and materials or material properties in order to give you specific performance, let's say.
Yeah,
Same idea with metasurfaces.
yeah. Meta surface is just a 2D version of meta material. So basically, it's just a planar thing instead of like original theory of metamaterial. Assumed that you have this 3D, so you can absorb signal, reflect, refract, everything. Whereas with a 2D version, you only a bit more restricted, but we still can do quite a lot. So instead of making it volumetric, we just make it planar. And yeah, it also um, applies quite a lot. So I should mention to um, higher frequency ranges because it becomes more attractive for higher frequency ranges since those planar structures become smaller, or at least they don't necessarily become smaller, but it becomes easier to make them smaller if you wanted to, and typically you do want to make them smaller. So for like a millimeter wave at 28 gigahertz, the structure would be of about this size, whereas if we target 3.5 gigahertz, and it's all related to wavelength. So if we target 3.5 gigahertz, it will typically be at least 1 meter in diameter. So basically, it is a lot more space that it will take, and it's not really cost efficient as much as it would be for millimeter wave. So again, we're targeting mostly like future networks and not existing networks, but yeah, and we also envisioning this integrated sensing and communications for future networks, where every position of the user will be known by default to the network. So we will be able to tailor our network resources accordingly and make those networks very energy efficient, which is exactly the problem with the existing millimeter wave installations, is that they are so power hungry that they basically, a few network operators tried to put millimeter wave base stations, but because they basically try to radiate omnidirectionally, it just fails to work because it consumes huge amounts of power, and it's just a very terrible idea. So instead, we kind of want to move to those point-to-point communication links with reconfigurable surfaces acting as a kind of interface between the base station and the user. That
Now,
that makes
when you
sense.
a bit, I think I'm you mentioned that it's like a mirror
Yeah,
prior.
yeah.
Okay, usually when this is my optics background jumping in here, and it's probably incorrect, but usually when someone says a mirror in the context of an emitter, it's almost like the mirror might be used as a focusing element.
So it's exactly what is, especially when you in a near field of that mirror, it acts as a lens. So
Got it.
it does exactly that. It focuses radiated power on your user device. So, and I don't mean your head, I mean the smartphone.
Yeah, right.
So we want to be this precise. We want to focus it on the antenna, not on the people.
Right, right. And so this would be compatible with analog, digital, hybrid beamforming, all the standard beamforming methods.
Yeah, because essentially the mirror is neutral. It shouldn't affect the channel at all. So um, yeah, it don't matter what beamforming you're using at the base station.
Got it. Got it. Okay. This is extremely interesting, and hopefully you'll do a video on it in the future because
I have
that
done
type of
one,
stuff is.
yeah,
Oh, you have done one.
but it's very introduction. But what I find frustrating with YouTube is that it doesn't really give you a lot of flexibility. Like if I make a channel on EMC and then suddenly I make a video about 6G, it doesn't like that.
Right. I see. I see.
It just doesn't advertise it. It really kills it. Like in particular, I made recently a video about not 6G, but for example, ingress protection.
Uh
Like
huh.
water, liquids, and the dust and things like that, which are kind of related to EMC, but is more of a mechanical test, so more mechanical engineering. And yeah, YouTube algorithm hated it. Like absolutely, it killed it. It it only showed it to 200 people, all of whom were my subscribers already, and that's it. And
Unfortunate.
yeah, it's really quite tricky. But I'll try to
Yeah.
find a way to link like I'll try to find a way to link those things like reconfigurable surfaces and EMC, maybe.
Well, I would encourage anyone who is listening to check out our show notes and go subscribe to the channel, and you'll be able to learn all about all this stuff with EMC. I know this is something that I have been trying to learn more about, as well as manufacturing. And we've talked to a lot of manufacturers recently especially folks more on the semiconductor side with packaging, but we've left out EMC. So I'm glad that you've been here with us today to talk about EMC stuff, and hopefully some folks will go subscribe and learn.
Oh yeah, absolutely. Please visit my channel, Dr. EMC, and also have a look at the PCB for EMC webpage. It's still under development, but there is a course you can purchase, and there is also the page for the PCB analysis tool, but you can only subscribe to the mailing list for now. But as soon as I get it finished, I'll notify you and let you know that it's available.
Excellent. We'll have links to all of that stuff in the show notes. Anton, thanks so much for being with us today.
Thanks for invitation, Zach. I appreciate it so much.
To everyone that's out there listening, we've been talking with Anton Tishchenko, better known as Dr. EMC, and the founder of PCBforEMC.com. If you are watching on YouTube, make sure to hit that like button, hit the subscribe button, and you'll be able to keep up with all of our podcast episodes and tutorials as they come out. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.